Alright, it's time to have a look at all the different ways that we can get our equation from the algebraic form into being a graph. Now we've done before a process called plotting graphs, which is a series where you have a whole heap of different values for your x that you substitute into your rule and find the corresponding y values. So let's recap that first of all. So as we've done before, we're starting with this point here, x equals minus 3, and the rule says the y value is just twice the x value and then add 1 onto it. So if we've got to go 2 times minus 3, that gives us minus 6, and then we add 1 on, we get minus 5. Next one, 2 times minus 2, that's minus 4, add 1, minus 3. 2 times minus 1 is minus 2, add 1, minus 1. 2 times 0 is 0, add 1, we get 1. Now as you're going, you should notice a pattern going on here. You can see each time we're going up by 2, so hopefully that should continue, and it helps to keep you on track. Let's check here. 2 times 1 is 2, plus the 1 is 3. 2 times 2 is 4, plus the 1 is 5. Let's check, are we still going up by 2 each time? Yes, we are. 2 times 3 is 6, plus 1 is 7. Now to graph these points, we've just got to go down here and put all of these coordinates one by one on. So minus 3 on the x, minus 5 on the y, minus 3, minus 5, and they join up here. Minus 2 is the next point, and its y value from the table we can see is minus 3. There it is. Minus 1, minus 1, 0, 1, 1, 3, 2, 5, and 3, 7 is up here. Then we just need a straight line to join those up, and we're done. So let's do that. Continue your line beyond the points that you've put on. It's only that you've only looked at those values from, only because you've looked at the values from minus 3 to 3 that your graph stops there, but in fact it just keeps going. We just can't be bothered finding any more points. That's enough. Okay, so here's our graph of y equals twice the x value plus 1, every point along there. Now let's just have a look and see if it's what we expected. We know that that point, this number here, this 2, tells us our gradient, which means that every time we go across 1, we go up 2. Yeah, that's what's happened. We also know that this plus 1 here tells us where we should expect the graph to cut the y-axis. It should be cutting at plus 1, and have a look. It's cut the y-axis here at plus 1, so I might just continue that up there. So remember, this number at the end always tells you where your graph cuts the y-axis. This number here tells you your gradient, and which means that every time you step across 1, you need to go up 2. So we can always check to see whether our graph is correct. We've talked before about the fact that it's really a bit of a waste getting all of these points when we really know you only need 2 points in order to draw a straight line. 2 points, get your ruler, join them up, and you'll have exactly the same thing as you have here without having to go to all the trouble to find those 7 different points. So in the next process, we're going to look at shortcutting this process by just getting 2 points. Let's have a look. And this method is called sketching graphs. It might not be quite as accurate as plotting. We're just getting a sketch of it, just a representation. There's 2 different ways we can do this. Let's have a look at the first one. If our equation is written in this form, and we should be fairly familiar with this, where this tells us our gradient, and this number here tells us our y-intercept. Now, as we said before, this number being the y-intercept just tells us that the graph is going to cut the y-axis there. What I need to know now is just one other point. Do I have a point over here, or down here? Somewhere that I can put a point and then use that with my ruler to span and get the line. We just need one other point, and it's totally up to you which value you choose to find. So the easiest one is just to go, all right, I'll just choose an x value along here. Okay, let's just choose x equals 2. Okay, I could have chosen 1, I could have chosen 3, oops, I could have chosen 8, it doesn't really matter. I'm just going to randomly say x equals 2. So if x equals 2, I'm going to substitute to find my y value. The rule says the y value is 3 times the x value you've chosen, which in this case is 2, plus another 2. So 3 times 2, well, that gives me 6 plus 2 is 8. So when x is 2, y equals 8. There's my other point. X equals 2, y equals 8. There's my other point. All that's left to do now is get my ruler and join up those two dots. And just extend it as far as you can. Don't just stop at the limitations of the numbers you've chosen. Okay, there's my line. This is the line y equals 3x plus 2. Much quicker than drawing up your table of values of each time. So all we needed was the y-intercept, which we read straight off our equation. Just randomly choose any x value you like, substitute that into your equation, get another point, join them up. Let's try another one. Use the y-intercept and one other point to sketch this graph. Okay, so let's break it down. Minus 2x plus 6. We can straight away see that this plus 6 gives us our y-intercept. Y-intercept equals 6. Over here, 6. There's one point. We just need one other point in one of our quadrants in order to join them up. All right, so any other number you like, random choice. Let's say if x equals, let's go minus 5. Randomly choose any number. So the y value is minus 2 times the number I've chosen, which is minus 5, plus 6. Oops, I've got it, not going to fit on, but that's okay. 2 times 5 is 10, plus 6, y equals 16. So when x is minus 5, y equals 16. When x is minus 5, y equals 16. I shouldn't have chosen 16, but it's right up here somewhere. Get your ruler, join them up. Okay, that is my graph of y equals minus 2x plus 6. Now you can see that me choosing a value like x equals minus 5 wasn't that clever, because by the time I worked it all out, I ended up with a number here that was outside of my axis. Not a big drama because I sort of worked my way around it, but probably best if you choose any number between minus 3, say, to 3, just to make sure that your y-axis is big enough. All right, let's have a look at another method of sketching, and that is where we get our axis intercepts, our x-intercept. So where does the graph cut the x-axis? Where does the graph cut the y-axis? Once we know those 2 points, it's just a matter of getting our ruler and joining them up. Now to make some sense of this method, we need to realise that any value that's on our x-axis, any point anywhere on our x-axis, if you were to write the coordinate, let's say, of this point here, I know that's at 11 on the x, 0 on the y. point down here is minus 12 on the x, 0 on the y. Over here it's minus 4 on the x, 0 on the y. This is 5 on the x, 0 on the y. All of these points on the x-axis have a y value of 0. So by making y equals 0 in our equation, by default we're actually going to be putting a point on the line. Let's see how that actually works. I'll just get rid of those. Alright, so here's our equation. Now you'll notice here that our equation looks a little bit different to what we've had in the past. This is in a form that we call intercept form, and if you ever see your equation written so your x's and y's are on one side of the equals and a number on the other, you know it's in intercept form, and the best way to sketch it is using our intercepts. Okay, let's continue on. To get an x-intercept, we make y equals 0. So here's our equation, 2x plus 3y equals 6. I'm just going to substitute y equals 0. So instead of y, I'm going to write 0. So 2x plus 3 zeros, so instead of y, write 0, equals 6. 2x, now 3 lots of 0 is just 0, so I don't even need to write that. 2x equals 6. 2 times some number equals 6. I know that that number has to equal 3. So my x-intercept is down here at x equals 3, remembering this is the x-axis, of course. So all I've done is, instead of writing y here, I've written 0. And then it's all just worked out that 3 lots of 0 is just 0. 2x is 6, x equals 3. Let's have a look what happens when we go the other way. To get the y-intercept, we make x equals 0. Now the reason for that is that any point on this y-axis, the coordinates of that are 0 on the x, 13 on the y, or down here, 0 on the x, minus 9 on the y. Every point on this x-axis has got an x-intercept, an x-coordinate of 0. So let's force ourselves to get a y-intercept by making x equals 0. So in this equation, I'm going to sub x equals 0. So instead of writing x, I'm going to write 0. So 2 zeros plus 3y is 6. 2 zeros is just 0. 3y is 6. 3 times some number is 6. Well, that number has to be 2. Here we go. 2 is my y-intercept. Get your ruler, join them up, and you have your line going through your x-intercept and your y-intercept. That is the line of 2x plus 3y equals 6. Make sure you've labelled 2 and 3. Let's have a look at another example. Here's our equation, 2x plus 4y equals 12. Same process every time. Let's get the x-intercept by making y equals 0. So 2x plus 4 y's, and y is 0, is 12. 2x equals 12 because 4 nothings are nothing. 2 times some number is 12. I know that if I can't work it out quickly, I can just do my backtracking with algebra, and I know that x equals 6. So now I know my x-intercept is 6. Now notice this example, I haven't actually got a nicely drawn up axis, and I just wanted to show you that you can do it very quickly. And this is the beauty of sketching graphs. I just want to go, all right, there's 6, x equals 6. I haven't bothered to rule up all of my minus and plus and my minus and plus. I'm just going to put 6 there. Let's have a look at the y-intercept. I'll make x equals 0. So 2x, and x